Hello and welcome back to Continuous Integration using Jenkins by Edureka. This is module 6 of this video series in which we are going to talk about metrics to improve quality. After completing this module, you should be able to understand concepts like code coverage, how to use PMD tool, how to use FineBugs tool, how to check and verify the HTML validity, how to work with reports using Java and CSS, and various types of Jenkins builds. For example, using a Gradle script to build system, shell script, or ant-based build systems. Now, the first topic of this video series is about the code coverage. So we'll try and understand what exactly code coverage is all about and how does it work. But before we start with code coverage, just want to reiterate that in the last video, we have spoken about testing itself. However, the testing which we spoke about in the last module, it was more about the testing with regards to how your code is functioning. For example, unit testing, integration testing, displaying test results, and how to ignore certain types of tests and things like that. Now, in this particular module, we are still talking about testing. However, this is more about code optimization, how you can make your code better and better, and how to reduce the technical debt. So code coverage is the first one, and basically it talks about the code quality. So in addition to normal unit and integration test build jobs, you set up a dedicated code quality build which runs after the normal build and test. So once those tests like unit testing, integration, and acceptance testing have been passed, then you run the code quality tests. And in most of the times, and as a best practice, it is always better to run these jobs separately, because code coverage analysis and many static analysis tools can be quite slow to run. And it is also important to understand and keep the code coverage tests away from the builds, as the code coverage process produces instrumented code which should never be deployed to a repository for production use. So before we move further, let's try and understand what exactly code coverage is all about. So code coverage is basically an indication of how much code of the application is actually executed during the tests. So in other words, code coverage, it's a metric that can help you understand how much of your source has been tested. It's a very useful metric which can help you assess the quality of your test suite. You can think of it as test of your tests. So basically you are testing how exactly your test cases are behaving, how much they are covering the entire code or not. It is very useful in particular for finding areas of code that have not been tested by the existing test suites, so that then you can rewrite your tests and make the changes in your testing framework and try to include and try to implement your test cases on as much code area as possible. It also gives an indication of how well a team is using good testing practices, such as test-driven development or behavior-driven development. So these are some of the popular tools. So Krabertura is the first one. It is offline bytecode instrumentation. Emma checks for offline bytecode instrumentation as well. Clover is source code instrumentation tool. And Jacoco is on-the-fly bytecode instrumentation tool. Before we move forward, let's try and understand what kind of testing is done through code coverage tools. So the types of coverage. So first of all, we have something called function coverage. This one basically talks about how many of the functions defined have been called. So if let's say you have 10 functions or 10 modules, whether all of them have been called or not. Then we have statement coverage. This one basically tells how many of the statements in the program have been executed. So basically we are dealing with the different types of statements. Now statement is different and line is different. So after that we have something called line coverage, which as you can expect, it is basically denotes how many lines of source code have been tested. Then we have something called branch coverage, which basically talks about how many branches of the controller structures have been executed. Now this one should not be confused with the branches in a source code management tool, right? Because anyways, we are working with only one branch when it comes to, let's say, Git or SVN. When we say branches here, we are talking about, let's say you have if-else statements, or let's say you have different constructs. So if all of them have been taken care into consideration or not. So all the various possibilities. We also have this thing called as cyclomatic complexity, we called it. We'll see that a little later in this video. Basically, it is checking, let's say if you have 10 different conditions. So all those conditions have been tested or not, which is in fact the next statement also checks for not exactly same, but similar thing, which is known as condition coverage. So this basically tells you how many of the Boolean sub-expressions have been tested for a true and false value. So now the good thing is that these metrics are usually represented as the number of items actually tested, the items found in your code, and as a coverage percentage. So total number of items tested versus number of items total available in your code. So that's how, and then it is shown at the end in the form of the percentage. Again, as we have seen in the slideshow, we have different tools to work with when it comes to code coverage. So if you talk about Java, we have Clover, Cubercula, Jacoco, as we have seen. If you talk about JavaScript, we have Blanket.js, Stumble. If you talk about Python, we have coverage.py. For PHP, we have PHP Unit. So for all the tools, you have different types of code coverage tools available. Now, important thing to understand is that, the question comes is that what is the percentage of coverage you should aim for? Do you want it to be 100%? Are you okay with 90%, 80%? So the problem is that there is no silver bullet in the code coverage, and even at times what happens if you have a very high percentage of code being covered, that can also be a problem sometimes, because that would mean that it's just not the amount of code which has been covered, it's the robustness of the code as well, or the robustness of the test as well, which you need to check. So but yeah, I mean, overall, if you see, we still say like if your code coverage is 80% or above, or if it is hovering around 80%, it is good enough. So let's move back to our slides. So in our case, we are using a code coverage tool called Cubercula. We have seen this already in one of our demos. Cubercula is one of the most popular tools when it comes to Java, and especially building Java on Jenkins, because Cubercula plugin gets integrated very well with Jenkins. It's like a default, and it also supports Maven based builds and base builds as well. So it's just a matter of calling in Cubercula plugin in your Maven pom.xml file, and then you can just publish the report. You can work with it. It works really well. So it works well with both Maven and Jenkins. And best part is it is an open source code coverage tool. So it is a tool basically to calculate the percentage of code utilized by tests and analysis, which part of the code lacks coverage, as we have seen as a general definition of code coverage. So this is the typical workflow. So when you call the Cubercula plugin, so it goes to the Java program, it checks the Java bytecode, and then it has internal algorithm to check how exactly it should be testing. There are certain parameters and certain algorithms which it uses in order to check the code coverage. And the important thing is that it instruments the Java bytecode during compilation. That's what it is going to check for. It is not going to check on the source code. Once that is done, you can definitely go ahead and you have an option of publishing that report in the form of HTML. Now, HTML report allows to quickly review the code status from the command line, and XML report is typically needed for parsing by the Jenkins plugin. So in Maven, you do not have to add any configuration to pom.xml. You simply need to call it, and you just need to mention in the goal as just mention that clean Emma : Emma, or clean Cubercula : Cubercula, depending on which plugin you want to call it. So again, Emma is also very well supported by Jenkins as well as Maven, and the process remains very similar to Cubercula. Maven plugin, which calls for the Java bytecode, and then you can publish the reports in HTML or XML, depending on what exactly you want to do with the report. So that brings us to the next tool, which is known as the PMD tool. Now, PMD stands for Programming Mistake Detector, as you can expect. It basically focuses on potential coding problems such as unused or suboptimal code, the overall code size and complexity, and in general, it checks for the good coding practices. It's more like a linting tool in traditional programming world. Not exactly the same, because linting takes care of the syntax. This one goes one step beyond that. It's basically an extensible cross-language static code analyzer. It finds common programming flaws like unused variables, empty catch blocks, unnecessary object creation, and so forth. So all these things, and then it helps you reduce your technical debt. So these are some of the rules and examples how it works. For example, empty if statements, broken null check, avoid deeply nested if statements. So you should not have if statements 3, 4, 5 level inside. And logger is not static. So there are certain criteria, certain algorithms for which it checks. And if it goes beyond that, it will report those things to you. And then you can go ahead and make the changes in your code base accordingly. Now, there is an overlap with some of the check style rules. So PMD does have some more technical rules and more specialized ones, such as rules related to JSF and Android, etc. Now, it also includes the good thing with PMD is that it supports all the major languages. It supports like Java, JavaScript, Salesforce, Apex, Visual Force, PLSQL, Apache Velocity, XML, XSL, etc. Not only that, it also includes CPD, the copy paste detector. CPD basically finds the duplicated code in Java. Not only Java, in fact, Java, C, C++, PHP, Ruby, JavaScript. So it has got a really good support base PMD tool, and that's why it is so popular. It also comes with inbuilt with Ant, one of the Ant tasks. You can just call it as PMD, and you can then fetch the PMD and CPD reports. And this is one of the examples how you define a PMD inside an Ant file. Similarly, you can do that within, this is, as you can see here, one of the task definition calls the PMD task. And in Maven, you can simply call the PMD plugin to work with. Similarly, you want to generate the PMD XML report, you need to invoke the PMD task as shown below. Once again, task definition, and at the end, ant.pmd task is what you need to call back. If you want to generate the XML report, you can mention target name as CPD, and then you can give all these parameters, the key value pairs. So minimum token count is 100 we have given. Format is XML. You give the output file. Basically, you give a target where you want to save your file, and so on. So you can place this XML rule set in project class path, for example, in src/main/resources for a Maven project, or you can put it in a separate module if you want to share the configuration between different projects. So you can call this, as we have seen, you can call this within Maven, or you can call with other tools as well. So in Maven site, you can call, or you can write Maven mvn space pmd:/pmd or pmd:/cmd to generate the PMD and CPD reports. So this configuration will use the PMD rule set in the src/config directory and generate a PMD XML report called pmd.xml in the build directory. And it will also run CPD and generate a CPD XML report called cpd.xml in the build directory again. So that brings us to the next tool, which is FineBugs. Now FineBugs and PMD, these are the tools which overlap a lot. So of course, reviewing your Java source code on a regular basis is always a good idea. And we have tools like PMD and FineBugs which help you out. But you need to understand which tool is used for what. And then according to your requirements, you can actually go ahead and choose at least one or maybe a combination of these tools. So FineBugs is another static code analyzer, very similar to PMD. But the biggest difference between PMD and FineBugs is that FineBugs works on bytecode, whereas PMD works on source code. And FineBugs can basically find things like, let's say, improper use of methods, unsafe casts. Let's say when something will always be null where it should not be. You have possible ignored exceptions, possible stack overflows, and things like that. So there's a lot of overlap between FineBugs and PMD, as I have told you already. So because of the limitations of working with bytecode or source code, each excels in their own area. So depending on how you want to do the analysis, whether you want to do it on the source code or on the bytecode, you can choose the tool accordingly. Now, if you see here, to run FineBugs, you could simply set up a FineBugs target as shown in the following example, this one. And as we have seen, FineBugs runs against the application bytecode, not the source code. So you need to compile the source code first before you can actually run the FineBugs to understand or to generate the report. So for Maven 2, we don't need to keep a local copy of the FineBugs installation. You just configure FineBugs in the reporting section as shown here. So if you see at the bottom, the screenshot, this is a screenshot of part of the pom.xml file where we are simply calling this FineBugs Maven-plugin, and then it will take care of the rest. Now, XML reports can be generated by running mvn site or mvn FineBugs:/FineBugs. And then once the report is generated, it will be placed in the target directory. So some of the important things to remember about FineBugs is that the first one is that FineBugs don't need to fine tune the rules as much as the other tools. You can list the individual rules you want to apply, but you can't configure a shared XML file, which is, let's say, shared between your Maven builds and your IDE. Because most of the tools which we are covering here, which we are looking at, they are actually configured or they are configurable with your IDEs like Eclipse or IntelliJ or some other tools as well. Now FineBugs comes bundled with an Ant task. So if you're working with Ant, you don't even need to call the plugin as well. It is pre-built and pre-configured. FineBugs needs to refer to the FineBugs home directory, which is where the binary distribution of FineBugs has been unzipped. So if you have not done that, you need to make sure it is there. And in order to make the build more portable, we store the FineBugs installation in project directory structure in the tools/FineBugs directory under your root directory. So this is another screenshot where, as you can see, task definition has been called as anttask.finalbugstask, and target directory has been mentioned as tools/FineBugs. So whatever reports are generated, they will be put inside that directory. So in order to work for PMD and FineBugs reports, you need to install the plugins through Plugin Manager. Again, it's as simple as installing and configuring any other plugin. All of these plugins use a static analysis utilities plugin, which has to be installed. So after the installation is done, set up the reporting in project configuration. You need to choose Publish FineBugs Analysis Results checkbox. And in a freestyle build, one needs to specify a path pattern to find where to look for check style XML reports. And again, as we have seen before in Maven 2 build, no need to specify the path, as Jenkins itself will find where to look for XML reports. So one important thing to notice here, or as a conclusion, that that PMD, FineBugs, check styles, these are some of the really very popular open source Java code analyzers out there. And as we have seen that there is a good amount of overlap between them. But of course, even then, there are some uniqueness to each of these services. Most of the places, as a general practice, what we have seen is that there would be a combination of these tools are being used. So for example, you'll find commonly PMD and FineBugs being used at the same time in the same project, or maybe PMD with check style. This is basically to ensure that all aspects of coding practice could be covered. Now, one report or one project which should be mentioned here is Sonar. So Sonar is one of the projects where you have a combination. Sonar takes care of all the things which you individually work with, let's say PMD, FineBugs, and check style. Now, it's really a big thing. I mean, it does a lot more than that as well. However, one of the biggest drawback to Sonar is that it requires a database and it requires a hosting on a web server. So you do need some configuration complexity to understand before you work with Sonar. On the other hand, if you're working with, let's say, PMD or FineBugs, they can be downloaded and running on source code in probably less than 5 minutes. So again, depending on your requirements, you can either choose a combination of these tools or you can choose Sonar. That is again completely driven by how you want to do things and what do you exactly want to achieve with your reports. So the next thing comes is verifying the HTML validity. Now, basically this validates the HTML pages against HTML and CSS standards. If you're writing one HTML page, you need to install the Unicorn Validation and Plot plugin. For a freestyle job and a build step, by selecting Unicorn Validator, you just need to do that. Select the right build step, which will be Unicorn Validator. For the site to validate input, add a URL to a site and that which you are actually allowed to test. You need to make sure that you have access to the website or the page which you are testing with this Unicorn Validator. And once you do that, in the post build sections, you need to check plot build data, and you need to add the details like plot graph, plot title, number of builds to be included. You just need to put a number there. Then what exactly you need to put in y-axis label and x-axis label. And then what kind of plot style you need to choose. So you can have different values there. You can choose area, you can choose histogram, and most of the standard charting techniques are actually supported there. So this Unicorn validation plugin uses the validation service as at W3C to generate a report on the configured URL. The returned report is processed by the plugin and absolute counts of the defects are taken. The summation is then placed in the property file where the value is then picked up by the plotting plugin. And if there is any kind of sudden surge in the warnings, then it reviews the HTML pages for repetitive defects. And of course, once you have gained the understanding, you need to do the reporting on the code complexity. Now, code complexity can be measured using cyclomatic complexity. So what exactly is cyclomatic complexity here? If I want to make you understand in very simple terms, cyclomatic complexity of a section of source code is the number of linearly independent paths within it. So let's say, for instance, if the source code contained no control flow statements, so let's say there is no if-else statements, there is no loops here, then the complexity would be 1 because there is one linear path which your code is going to follow. Let's say if the code had one single condition if statement, so let's say there is one if statement, so of course for a if there will be a corresponding else as well. So then there would be two possible paths through this code. One where the if statement evaluates to true, and the other one where the if statement evaluates to false. So of course in this case the complexity would be 2. Now similarly, 2 nested single if conditions or one if condition would produce a complexity of 3. So that is how you work with the code complexity. So that's what we say when we say this involves measuring the number of different paths through a method, because you have multiple methods and each method can take you or lead you to different possible options. So using this metric, complex code typically has large numbers of nested conditions, statements, and loops, so which makes the code harder to understand and to debug. So this is basically based on the assumption that the code which is complex and poorly tested is likely to contain more bugs than simple well-tested code. And then we have something called Coverage Complexity Scatter Plot plugin, which is designed to let you visualize this information in your Jenkins build. So why do we measure this code complexity? The most important reason is to get rid of the technical debt. Now, what happens is if your code is more complex, then it would be taking more time for you to refactor if needed later on. If it is simple, then if it has got less complexity, then it will be easier for you to maintain the code. So the main reason or the main aim behind checking the code complexity is to make sure the code complexity is less, and so as to, in turn, what it helps you to maintain the technical debt so that you have less and less technical debt. So this is how it looks like. Use this plugin, Coverage Complexity Scatter Plot plugin. This is how the overall graph looks like. And this one basically displays an overview of the state of the code in terms of test coverage and complexity. To drill down, to investigate further, you can click on any point in the graph and see the corresponding methods with their test coverage and complexity. So this is a clickable graph where actually once you click, it will tell you which test is being there, has been done there, and what exactly is the result. And you can actually go ahead and check out all those details. So next we have reporting with Java and CSS. Now Java and CSS is a software metrics tool that calculates two types of information. So the first one is the total number of source code lines in a package that are active, commented, or Java doc related. Secondly, it calculates the complexity of code based on how many different decision branches exist. So it is something similar to code complexity or the cyclomatic complexity algorithm. And then Jenkins Java and CSS plugin ignores the complexity calculation and focuses more on the understandable line counts. Now, NCSS stands for non-commenting source statements. Now, how does Java and CSS helps here? Have you ever wondered how many lines of code or how many classes are there? Let's say your JDK. Or are you curious about the size of your own project? Or let's say, how do you want to keep track of your work-related progress? That's what Java and CSS is for. It is a simple command line utility which measures two standard source code metrics for the Java programming language. And then the metrics are collected globally for each class and for each function. So reporting with Java and CSS, for that, what you need to do is you first need to make sure that the Java and CSS plugin is installed. And again, the installation procedure is just like what we have done before for any plugin installation. For a Maven based project, under the build section for the goal and options, you need to type clean space Java and CSS : report. And once that is done, under the build settings section, you just need to check the publish Java and CSS report, and that will be it. So some of the terms to understand in Java and CSS report is if we talk about classes, so this is talking about the number of classes in the package. Functions corresponds to number of functions in the package. Java docs basically corresponds to the number of different Java doc blocks in the package. This is not exactly fully indicative because most modern IDEs generate classes using boilerplate templates. So therefore you can have a lot of Java doc generated at poor quality, creating misleading results. So this is not something very useful here, but yes, classes and functions, they give you the accurate understanding of how many classes and how many functions you have in your code base. NCSS basically, as we have seen, stands for non-commented lines of source code. That is what it shows. JLC stands for number of lines of Java doc. SLCLC basically tells the number of lines that include only a single comment, and MLCLC, number of lines of source code that are part of multi-line comments. So that completes the lecture on how many different types of code analysis or code quality analysis. Now let's take a look at some of the ways how we build our Java-based code base through Jenkins. So the first way is Jenkins with Gradle script build system. Now Gradle is an open source build tool for the Java virtual machine. So Gradle it's a counterpart for, let's say, Maven or Ant. Build scripts for Gradle are written in a domain-specific language, and it is based on Groovy. Groovy, as you know, is the language for Jenkins as well. When you work with Jenkins pipeline, you can use Groovy scripts to define your stages and builds, etc. Gradle implements conventional over configuration, allows direct access to Ant tasks, and uses Maven-like declarative dependency management. Now, the concise nature of Groovy scripting allows to write very expressive builder scripts with very little code. It is very new compared to Maven, however, it has gained a lot of popularity because of the benefits it provides. So there are two different ways to run your Gradle builds with Jenkins. So basically you can use a Gradle plugin for Jenkins, or you can use Gradle wrapper functionality. So as you can see here, you need to install the Gradle plugin in the usual way again. In fact, in most of the cases, you will find it pre-installed. This is one of the suggested packages or suggested plugins to be installed when you initiate your Jenkins server for the first time or the Jenkins instance. And once you do that, once the plugin is installed, a new Gradle section will be displayed in Configure System screen, and you can add the Gradle installation to be used over there. So this is where you configure, just like we have done for Maven in one of our earlier class. You need to mention where exactly your binary is located and what is the version. You can put a name here, and through this name, you are then going to call it inside your Jenkins jobs. Now in a freestyle build job, you add a build step to invoke Gradle scripts, just like we used invoke Maven based scripts. And it basically lets you add Gradle specific settings to your build job. While running a Gradle build job with unchanged sources, Gradle runs its build in incremental manner. If the output of a Gradle task is still available and the source haven't changed since the last build, Gradle is able to skip the task execution and marks the according task as up to date. So this is more like something similar on the lines of getting idempotence functionality, which you get with typical configuration management tools like Chef or Puppet or Ansible. So Gradle is smart enough to understand when it needs to be built and when it can simply skip and mark it as complete. This incremental build feature can decrease the duration of a running build job considerably. So basically it is something like when you have storage solutions where you have incremental backup, right? So you do a backup only of the tasks or files which has changed. So that is something very similar. The concept is very similar here as well. So it is doing the build of the code base which is changed. If something hasn't been changed, it doesn't need to rebuild it. And if Gradle evaluates the task, the test task as up to date, even the execution of the unit tests is skipped. So Gradle doesn't keep it as a stale. It basically mentions that the test has been completed because it sees it doesn't need to change anything. So if nothing has been changed, there is no point in running the same sort of tests once again. The next option is Jenkins with shell script build system. Now, basically shell scripts are the ones which can be executed using Jenkins under build option within execution shell. So this is something like let's say you already have a script, you already have a shell script which you have been using all this while for your, let's say, build or execution or deployment. Jenkins provides you a way to directly call those scripts just like you have been doing before. So shell script which is entered in execution shell is simply built and saved, and output is displayed on Jenkins console output. So Jenkins will call that script, run that, do the execution, and once everything is complete, it will provide you the output screen within the Jenkins console, which we have already seen a number of times. So this is what you need to do. You need to go to the build section of a Jenkins job, and then you click on add build step. This will be one of the options, execute shell, which you need to choose. In similar fashion, if you have, let's say you're working on Windows machines, then you can choose the first option, which says execute Windows batch command. And then you have, as you can see here, we have options of Ant, Gradle, and Maven as well. So these three are typically pre-installed when you initiate your Jenkins in the standard way. Once that is done, you can just mention the commands which has to be executed. So you can just put it over here. So in this case, we have given some dummy commands to you. And in fact, these are all parameterized builds. So when you say $, that means that Jenkins will expect these values to be given as parameters in a parameterized build. Once that is done, you can see the console output like this. So it will mention all those details. Now we are yet to see a parameterized build. When we see this, we can understand how exactly we can work with it. This is basically a way to provide the variables or the parameters or initiate your variables at the runtime. When you're running the Jenkins job, every time you can provide a different value to initiate your variables defined. Alright, so the next one is Jenkins with Ant build systems. Ant is, again, it's a Java based build tool, and again one of the very popular ones apart from Maven and Gradle, of course. So Ant stands for another neat tool. That's the acronym for it. Main purpose of Ant is to build Java based applications. We can run many built-in tasks in Ant, for example compile, assemble, test, etc., just like what we do in Maven. So we need to define the tasks in a build.xml file according to which Ant executes the task. So this is the place where there is a big difference when it comes to Maven versus Ant. So Maven expects pom.xml file, whereas Ant expects build.xml file. In fact, even in Gradle, you have a build.xml file, which has all the instructions to define the task and then call them at the execution time. And we can also execute shell commands through Ant as well. So while configuring a job, you just need to choose invoke Ant. We have seen the screenshot already. So if I just go back, as you can see here, this is the screenshot. So you just need to select this option called invoke Ant. And once you do that, it will give you all the options. And once you come here, just like we have done with Maven and Gradle, you just need to put all the details or configure your and environmental variables. Once that is done, you just need to, under the advanced option, configure the extra parameters, choose the build file. If you remember, when it was Maven, we used to mention pom.xml in our file section. In this case, we are using build.xml, right? And this is the file which and reads when it is executing your code base to build. All right, so that brings us to the demo for to create a job to get the metrics. So we'll be using this Java NCSS plugin to get how we get the reports. Steps are simple. You select a project, you create a new job, and then you configure the job, configure the build for Java NCSS. Then you can also configure for FineBugs analysis tool as well. The instructions are already given in the demo document 1 of this module, and let's take a look at how we work with it. So I need to come to my Jenkins instance, which we have been using so far for all our demos. As you can see here, 172.28.28.145. This is the instance which we have been using so far. This is the SSH screen. If I go ahead and check, as you can see, this is the IP address. This is one of the local Vagrant machines which I have created for all my demo purpose. And during our Jenkins distributed builds, this will become our Jenkins master, and then we will have rest of the machines. We'll create maybe a couple of more machines to create Jenkins slaves as well. So if I want to check if my service is up and running or not, I can just do that here. Of course, it should be up and running because we have already seen we are able to access Jenkins. As you can see, it is up and running absolutely fine. So let's go ahead and create a project. So let's give this name as Java NCSS report maybe, or just keep it as Java NCSS. That should be good enough. Let's create a freestyle project, which is the easiest and the quickest to work with, most flexibility. We will use our Git repository, which we have been using so far. So which is, I don't have the exact path here. So GitHub, Eureka DevOps it is. And I think it is Jenkins demo. It's taking me to the Eureka page. So if I just go ahead and click this, let's see if I'm able to find the direct. Let's see if it takes us to the right directory. Yes, it is. So this is the one I'm interested in. And I just copy the URL and I can simply paste it here. Once I hit tab, the red screen or the red message should go away. Yes, it does. Now, once this is done, what I need to do is I need to basically start a Maven job. So I go ahead and click on invoke top level Maven targets. I will choose local Maven as my option. I have two different versions, so I'll stick to local Maven, which I have configured as my Maven 3.5. In the goals section here, I need to mention like this: Java NCSS report. That's all I need to do. And of course, under the advanced section, I need to mention the pom.xml file location. Now, in our case, pom.xml is not in the root directory. It is actually inside this Maven project. If you see here, this is the pom.xml directory. So I need to mention it like that. So it is Maven project, and be careful with the uppercase, lowercase. So M and P is in uppercase, rest all lowercase, and then slash pom.xml. So that should be it. But since we are using this Java NCSS, let me just save it first. Since we are using Java NCSS, we need to make sure that the plugin is installed there. So I go to Manage Jenkins, Manage Plugins. If I go to Available, let's go to Installed first, or maybe let's check in Available first. So if I go to Java NCSS, I don't see anything here. So that would mean that it has already been installed. So let's check it out. I go to Installed tab, and if I do a Java NCSS, as you can see here, Java NCSS plugin is already installed and it is enabled as well. So this plugin integrates Java NCSS reports to Jenkins. That's what it says. That's the description of this plugin. So I can go back. It looks okay. There is nothing to be done anymore. If it is not there, you just need to make sure that the plugin is installed and enabled before you run this job. So now I can come to my Java NCSS. As you can see, it is gray at the moment, which would mean that it has never been built. So let's go ahead and let's check the first build here. As you can see, it has started. So let's wait for a couple of seconds. It should not take very long. So as you can see here, this pom.xml, and it has started already. Test and then Java NCSS report. It is running all these things in particular order, how we have defined it in the pom.xml. As you can see here, it tells me a small warning. However, it has run the test and there is 0 failure, 0 errors and 0 skipped. And if you see here, the important portion at this location, if you see, it has the reaction summary. If you see, it has got all the multi-1, multi-2 and multi-3 multi-modules build have been successful, total time taken, finished at so and so time, and at the end it is a success. So the reports have been published in the Artifactory test app test. And as you can see, Java NCSS has been given. So Java NCSS Maven plugin 2.1 report was called for doing all these tasks for you. So that's how you run one of the Java NCSS plugins. So again, this is very similar. We have already seen about the Kubertura plugin. So all these plugins you just need to download and install, make sure it is installed, and then you can then run them accordingly as per your requirements. So whether it is PMD, whether it is Java NCSS or Kubertura, all these plugins will work in pretty much the same way. All right, so it looks like the completion of the module. And once you have gone through this module, you should have a good understanding of how to find out the code coverage, what exactly we mean by that, and how to use the Kubertura plugin, which is one of the most commonly used plugins. We have Emma as well, but Kubertura I believe is the most commonly used plugins or tools when it comes to code coverage for Java. How do we activate and use the PMD plugin, FineBugs plugin for Jenkins and how to work with them? How do we verify the HTML validity? And we have seen in theory and in practice as well how to work with Java NCSS reporting. And we spoke about how to work with Jenkins when it comes to Gradle based build, Ant based builds and shell script based builds. Now this module was more on the theory side and less on the practical side because we have a lot of concepts to understand, right? Once you understand the concepts, putting them into practice or putting the right plugin is not exactly a very big deal. So if needed, just go and watch this video again to understand all these concepts. You have a lot of information available on the internet to understand all the code quality analysis tools. How do they work? What are the pros and cons and things like that? And thank you for watching. See you in the next video.